Welcome everyone to the Great Lakes Permaculture Design Collaborative.
We are a trio of permaculturists.
Rhonda Baird from Bloomington, Indiana.
William Faith from Chicago, Illinois.
Milton Dixon from Ann Arbor, Michigan.
We're teaming up to create a hands-on learning experience
that can catapult you into a regenerative practice of your own.
glpdc.info
will send you to the host of our next Permaculture Design Certificate course.
So today we're going to talk about aquaculture and how it relates to permaculture. This is Rhonda Baird, and I'm here with Milton Dixon.
Hello.
And William Faith.
Hello.
And when we are talking about aquaculture as it relates to permaculture, we can really dig into this permaculture flower. Aquaculture has a lot to do with reincorporating aquatic systems into land and creating places where natural systems can reestablish. If we talked about forest loss on the continent, we might be looking at places where we've lost, 96 to 98% of original forests. We've lost comparable amounts of aquatic systems or wetlands throughout much of the Midwest. So reestablishing aquatic systems can be helpful. Aquaculture can happen inside of buildings or a connection with buildings, relationships. We're talking about aquaponics there. With tools and technology, there are different tools when you're tending aquatic systems that are in use, that are very specialized. With technology, if we're doing aquaponic systems, we can get very technological about filters and pumps and things like that. There's a lot of education and culture that can be developed regarding aquaculture systems, helping people to appreciate the abundance and diversity in those systems and how to use them both for the benefit of people and future generations. There's the health benefits of being connected with wetlands and the specialized plants and things that are connected with those, as well as the well-being of the species that are dependent on aquatic systems for their homes. Aquaculture can allow us to use edge pieces of land to create an economic income. And they're often places that have been put into commons property or edge properties. So community governance is affected and land tenure as well.
I think also it's a reflection that the health and well-being of an aquaculture system, of our wetlands and wet areas, reflects back on our overall health of the rest of the terrestrial systems and even of ourselves.
So the first thing to understand about aquaculture systems is to think about the ecology, the relationships, who is eating whom and taking advantage of wastes, or plants being eaten by invertebrates being eaten by vertebrates, those kind of relationships. Thinking about the inputs and outputs of this kind of ecology. Thinking about, again, sunlight, photosynthesis as the generator of abundance in the system, temperature variations, which we'll get to here in a second, all those energy flows and cycling of materials to support diversity. And aquatic systems are some of the most abundant and diverse systems on the planet, and they are often very vulnerable because of water as a medium.
In this diagram, the tertiary consumers, they really are a great indicator. If they're in good health and there's abundance enough for them, then you know that your system is really, really humming, really working well.
It's one of those, if you build it, they will come scenarios.
Mm-hmm. Yeah. So in this slide, we have a vernal wetland, which is wet only in the springtime and then dries up and has different plants and animals using the space at other times of year. So we need to think about durations of wetlands. They don't have to be wet all year long in order to be valuable. So these are some of the most valuable wetlands there are because there is so much variation and so much edge, not just in space, but in time. as well as in the bottom right here we have Yellowstone with its hot pools, which is a different kind of thing. It's a reminder to think about specialized ecosystems where there's very cool water or very hot water, and the different limits and limiting factors involved in design and situation.
In Michigan, I know we have those vernal wetland systems where in spring there's standing water and then the rest of the year there's not. And they do have very interesting ecologies. Little shrimpy things that live inside and all sorts of stuff.
I think, unfortunately, a real prevailing way of looking at these is in some cases where they're inconvenient, we tend to shut them out. Where Los Angeles Eco Village is located used to be a hot spring, and they used to have a hotel there that the hot springs was a feature, but eventually it fell out of vogue, so they actually just shut the thing down, cemented over it, and put new apartments there. It's a very unfortunate way of looking at things.
Mm-hmm. Yeah, and when we're thinking about limiting factors, there's the physical here, but also our civilization, our society is very much built on the idea that standing water is a vector for disease because of mosquitoes, and that's a real threat. But also, then the response has been to drain wetlands whenever possible. And so if you start to work with wetland systems, you may run into Army Corps of Engineers or have to develop relationships with them, and they have very specific invisible structure kinds of ideas about what should happen with wetlands. Chinampas, this is a picture of Xochimilco in Mexico City, where the word chinampas, the idea of chinampas is very well known from history. And these systems that interpenetrate terrestrial and aquatic systems were very much used in societies and civilizations where you built up land in a wet basin, like in Mexico City, or you introduce standing water in drier plains. There are examples of these in South America and other places around the globe. And the idea is that the land base was built up above the water level a bit, and so that you could grow crops or have cities, houses. There were small cities on these, and you could use water to sub-irrigate, to protect from frost, and to transport people and goods, as well as using the silt and things that built up in the aquatic systems to build up the soil fertility.
These are such fascinating systems. My old teacher, Scott Horton, had a lot of direct experience with them, and it's just amazing all the things that come about as a result of them. The sense of community, the way that they work together, and such an efficient way of delivering goods back and forth, and really just working with natural systems as they exist. An easy way of dealing with this would be to dam the water off or something along those lines, but this is actually really making use of it and turning it into its own unique little ecosystem.
Yeah, I'd like to highlight the ease of transporting goods in these systems. The water is the easiest way to transport goods. Provided you have a boat, you can transport a long way, only using a little bit of energy.
So building on that Chinampas idea, wherever we can extend the edge between fingers of land reaching into water or water being pulled up onto the land, then we get more resilient ecosystems. And you can see that in this next slide with the terrace, the rice paddies down in the lower left-hand corner. Again, these systems are hundreds of years old and extremely productive when they are tended. To me, when I think about cascades of water, this is one of those landscapes that come to mind. Besides building ponds and dams and dikes or building chinampas into ponds, on the bottom right here we have another old system that we've started to rediscover, which is indigenous peoples in Europe and on the North American continent would build weirs, W-E-I-R-S, which were basically stone walls that the sea would wash over, and then they would go in when the tide receded to harvest whatever was brought in that was useful. Again, when you have a coastal system that's healthy and there's a lot of abundance, that kind of culture is a lot of abundance, a harvest without much work, that you can come in and harvest and come again.
It's very passive.
That's right. The upper left-hand corner is an example of aquaponics, where you are using aquaculture systems inside of a building. As a designer, some of our least favorite ways to incorporate aquaculture, because it requires a lot of energy for pumping water, for heating elements, and there's a lot of embedded energy in the buildings and beds that are used to produce these kinds of systems. And they require maintenance over time. So they're very energy intensive systems.
They're also incredibly fragile systems that they can be upended and practically destroyed just with the loss of power for a day, or overfeeding.
Even just the biology of the system itself is very fragile. You can have an ammonia spike that will kill all your fish in no time at all. And they're very, very input intensive. Just really, really a lot of management goes with it as well.
The reason to do them is urban systems they make more sense because you already have so much embedded energy in the system around you and very little opportunity to develop some more natural aquaculture systems. On the upper right, we have just even a very small channel of water in a backyard. And this is there to remind us that even very small pools of water that are there will dramatically increase the amount of biodiversity in the form of insects and birds. In 2012, I had many different species using my backyard pond as a watering hole just because there was a drought and it was one of the few reliable sources of water available within maybe a couple of square miles.
As I had mentioned in my system, when I first put the first little tiny pocket pond in that I added, the change in the system was palpable. It was immediate. And then when we expanded to a slightly larger pond, even further so. Who turned up, what turned up, the behavior of the system all changed in a good way in very short order.
Yep. So there are many different ways to work water into the landscape, and we should do so whenever possible. Mollison had a rule that if you had 15% of your landscape in water features, which could be tanks or ponds, you were supposed to be able to survive any drought because you could rely on it for irrigation. So when we get into designing water systems, whether that's with ponds or tanks, we can think about different kinds of elements to incorporate. We can intentionally choose those, and sometimes we also have to recognize that things will just show up in an open system. So if you have a closed system like an aquaponics system, you have more say in what's happening, but wading birds and others will actually bring in minnows and other species. So your open ponds will have all kinds of surprises for you as time goes on. But when you are choosing what to put in your aquaculture systems, you want to choose species that are adapted to your climate, who can make it through a hot summer or a cold winter, and be open to variety. So carp and perch are pretty hardy and excellent in an aquaculture system because of their ecological function, mostly eating plants and keeping the system clean. Milton, do you want to talk about tilapia?
Well, a common fish in aquaponic systems that I've seen is tilapia. They're a warm water fish. 70 needs to be the average temperature, and I think if it goes too much further below that, they'll die. And then I've kind of heard some strange things about the market for tilapia, that they only want a certain size fillet that's not possible to get using natural means. So they may not be your best choice. Although I've also seen them used, it was a great stacking of functions. Since they required heated water, growing power in Milwaukee, they would heat the water in order to provide the warmth for the greenhouse as well. So they wouldn't heat the greenhouse, they would heat the water.
Yep, they do that. And the main species that growing power uses are tilapia and lake perch. And so they have two different systems with two different temperatures. And that also allows them to grow different plants off of those as well. It's a different strategy.
The lake perch is interesting too because that's a fish that was commonly available in the Great Lakes, but no longer because of the lead contamination. And so bringing that back as a local fish, but in a cleaner environment. And they'll survive over the winter outside, given the right conditions.
And they're sold out months in advance for them. Restaurants are buying the harvest before it comes by a considerable margin. It's in very high demand.
In the bottom left-hand picture it's a picture from Yunnan province in China of a fisherman starting to harvest freshwater shrimp, which is a valuable crop, especially since here in North America, a lot of our shrimp comes from the Gulf of Mexico, which is heavily polluted water. The idea of freshwater shrimp from some place like Kentucky Seafood, which is a company in Kentucky, where there's more or different kinds of supply, is valuable. And so thinking about creating systems where there are these different kinds of harvests is valuable and potentially extremely economically viable in our systems. So in our aquaculture systems, we want to think about placement in the landscape for the maximum benefit in stacking functions. Aquaculture systems near buildings or gardens where we could get multiple benefits from radiant heat or sub-irrigation into cultivated systems, terrestrial systems is helpful. Thinking about where we can put ponds on slope to either gravity feed into cultivated systems. And then just recognizing the complexity of the ecosystem by choosing appropriate fish species, plant species within the pond or tank, and then edge species if we're doing ponds. We never want to leave bare slopes down into the water. We want diverse polyculture of plants, and a lot of those we want to think about in terms of their ecological function primarily, but also their yields as mulch or food or medicine or fodder for other animals.
One example that I'm pretty fond of is there's an example of a pond that's at the bottom of the system, but it acts as the trap for all the nutrients that are running off in the system or any kind of sediment. And the plants are harvested and then brought back up to the top of the system to kind of renew the cycle.
In a different version, I know at Quail Springs, they have a system of gabions for a seasonal creek that runs through their land, and they have silt traps built into them, and they'll go and harvest the silt out of that and then use that on their gardens.
Yeah, so the properties of water, how it will collect and move materials, using that, thinking about that as we design.
Absolutely.
Mm-hmm.
We think of these systems in terms of their water holding capacity and the things that live in the water, but the truth is that aquatic systems build soil faster than any other system, even than forests. So collecting all that silt or the mulch or the fertility makes a lot of sense. So in this slide, there's a picture of an iris. It's a great emergent plant. It's beautiful. And there's actually several of those in my pond. So we're looking at a picture of my pond from 2014, a couple years, 3 or 4 years after it was built. And that pond was hand dug. It holds about 1,600 gallons of water. So it's not a tiny pond, but it's not huge either. It has a shelf all the way around it with a deep pocket in the middle, about 4 feet deep, so that fish can overwinter. The edge closest to us in the image is shallow. It's sloped so that about a third of the pond is wadable. And that was designed intentionally so that birds and animals could get in and out of it easily, but also kids, so that young children could explore what was in the pond and be safe. Like I mentioned before, the pond has an incredible amount of insects and birds and other things coming to visit, and it's aerated only with plants. So at this point, here in 2016, it's covered in duckweed, which is doing a lot of the moderation of the environment, and then emergent plants that are pumping oxygen down into it. And it's home to fish and salamanders and frogs and all kinds of things. It's been the home to turtles. So a lot of diversity.
And Rhonda, you mean by emergent plants, plants that emerge from the water?
Right. Like this iris is an emergent plant.
Right.
Not long after the pond was built, a couple of years, the kids were exploring the pond, and they were super, super excited when they found a couple of salamanders that were using the space. And just because salamanders are so environmentally sensitive, the fact that our pond was home to salamanders was very exciting for us.
Nice.
So when we're designing systems, we want to think about what's upstream and downstream, where the water is coming from. In my little pond, there's not a stream leading to it, but it's downslope from most of the neighborhood. So there are systems in place to capture and filter water before it enters the little pond. And then downstream, ultimately all water ends up in the ocean.
I think that's important to know, roughly speaking, where you are in the watershed. You may not have a stream on your property, but no doubt there's one within close proximity to you. Even if it's underground, paved over, whatever, it's there. That water has to go somewhere. There's a lot of water that falls. It adds up quick and on the landscape.
Mm-hmm. And we can think about where that goes. So with my pond, the idea is to have gray water system feed into that pond eventually. And then the overflow goes into a swale system, which is also a pathway that is my main growing area. So I'm using as much of the water and filtering and cleaning it before it leaves my system.
And those are considerations whenever we're looking at water. Water enters our system. What can we do with it? How can we improve the quality of water before sending it downstream?
Slow spread and sink.
Yep.
And then here at the end, just to point out, and I mentioned earlier that if you have open aquatic systems, I think William said, if you build it, they will come.
Indeed.
And all kinds of things will come and use that space. And that's part of, I think, our third ethic with permaculture is to design for and welcome the diversity of species and beings that will use the space.
Having these guys show up is just indicative of good design.
Mm-hmm.
It's the kinds of feedback that you're looking for in any system.
Mm-hmm. So today we talked about aquaculture and some of the design considerations for aquatic systems, thinking about how much to incorporate into a landscape, aiming for 15%, where it might go if you have slope, to think about placement for multiple functions, species consideration, plants, and how this relates to our permaculture ethics.